Alright? Now, there's another way you could do this same problem using logarithmic differentiation. So, start with y equals x to the sine x, and then ln of both sides. Ln y equals ln of x to the sine x, and that's using property of logarithms. Bring the power in front, sine x times ln of x, and then take the derivative of both sides, so you're going to get 1 over y dy dx equals, and then take the derivative of that right side using the power rule, and you're going to get 1 over x sine x plus cosine x times ln x. And then multiply both sides by y as usual, and then change y back to x to the sine x, and you've got your answer. Alright, let's go on to antiderivatives then. Now, we know if a is greater than 0 and u is a differentiable function of x, then a to the u is also a differentiable function of x, and the derivative of a to the u is a to the u ln a du dx, or u prime a to the u ln a. Now, if a is not equal to 1, so that ln a is not equal to 0, you can divide both sides of that equation. Well, let me write the equation. So the derivative of a to the u, which is what I just said before, a to the u ln a du dx. Okay, that's on page 476, by the way. You can divide both sides of this equation by ln a, as long as ln a is not 0, so that's assuming a is not equal to 1. And so you're going to get a to the u du dx is equal to 1 over ln a d dx of a to the u. Alright. Basically, I just switched sides here, and I'm dividing both sides by ln a. So that ln a is canceled out, and then you've got 1 over ln a on this side, so that becomes this right there. And so what you have here is a to the u du dx equals that. Okay? Now, integrate both sides with respect to x on this one. So what you have then is the integral a to the u du dx is equal to integral 1 over ln a, and then you've got d dx of a to the u dx. Alright. This 1 over ln a, since a is a constant, 1 over ln a is a constant, you can bring that in front. 1 over ln a in front, and you've got d dx of a to the u dx. And then this is equal to 1 over ln a to the u plus c. Now, if you rewrite the first integral here in differential form, like on page 251, what you get then is the integral of a to the u du equals basically what we have here. Alright, so that equals a to the u over ln a plus the constant c. So here's some examples, alright? So in other words, here's a formula for integrating any base a to some function here, u. Alright, so let's take the integral of 2 to the x dx. Using our little formula, that's 2 to the x over ln 2 plus c. Simple. Alright, how about something a little less simple? Let's take integral of 2 to the sine x. Now, here we have base A is 2, and u is sine x. Alright, and let's make it more interesting. Put a cosine x next to that, dx. Alright. So, we can do a u substitution on this one. Let u equal sine x. And then du is cosine x dx. So the u here covers that power, and the du covers the rest of this integral here. And now what we have then is the integral of 2 to the u du, which, as we all know, is 2 to the u over ln 2 plus c. Or, going back to our original x's, that's 2 to the sine x over ln of 2 plus c. Alright. Well, let's talk about the derivative of log base a of u. The derivative of log base a of u. So first, like we've done before, we'll change it to a natural logarithm. Now, if u is a positive differentiable function of x, then the derivative of log base a of u is equal to the derivative of ln u over ln a. Now, how did I get that? How did I get ln u over ln a from log base a of u? Well, that's a change of base formula from pre-calculus. If you have a log to any base a, you can change the base by using the change of base formula. And so this is equal to this. So I want to change the base to base e. Alright? So I'm changing from base a to base e, and I'm using the formula for change of base. Okay, that's all there is to that. So we already know how to do these. This is equal to 1 over ln a, which is a constant here, times the derivative of ln u. Okay, and that's equal to 1 over ln a times 1 over u prime over u, or you could write that as 1 over u du dx if you want to look more impressive. Alright, so that shows you how to take derivatives of log of any base a. Alright, that would be 1 over ln a, and then multiply that by 1 over u du dx, or you could write it as, instead of du dx, write u prime, and then u times ln a. So you can see it's basically the same thing. U prime over u ln a. Alright. So let's do an example or two. Let's just do one, actually. So let's take the derivative of the log of 3x plus 1. Now, according to the usual convention, log without any power, or rather base number written, is considered base 10. At least that's true in most lower level math courses. Sometimes you'll see that, and that means log base e. In more advanced mathematics, well, for our purposes, this is log base 10. Alright, so this is equal to, again, using the formula, a is 10, u is 3x plus 1. Alright, so it's going to be u prime, that's going to be 3, over u, which is 3x plus 1, ln of base a, or ln 10. Alright, so that's 3 over ln 10 times the quantity 3x plus 1. Alright? So you just plug it into the formula. Now let's talk about integrals involving log base a of x. So to evaluate integrals involving base a logarithms, you convert them again to natural logs. Alright, so let's take a look at this example. Integral of log base 2 of x over x dx. And I can change the base to an ln. Alright, so use the change of base formula on log base 2 of x. That's ln x over ln 2. And you can bring the 1 over ln 2 in front. It's a constant. So you have ln x over x in the integrand, or as the integrand. So now you can do a u substitution. Let u equal ln of x. And so du is 1 over x dx. So that covers everything we have except the 1 over ln 2. See, the u covers that, the numerator. The du covers the 1 over x dx. And now we are missing a 1 over ln 2, so multiply both sides of this equation by 1 over ln 2. And then that covers everything. 1 over ln 2 du equals 1 over ln 2 1 over x dx. Alright, so now what we have is 1 over ln 2, which is a constant, times the integral of u du. And that's a simple antiderivative. This is equal to 1 over ln 2 times u squared over 2 plus c. Alright, so going back to the x's, that's 1 over ln 2, or let's write that as 2 ln 2. Put this 2 next to the ln 2, so I've got 2 ln 2 times ln squared of x plus c. Alright. Okay, so that about covers that section. Again, read this section in your book as well. There are other examples there that I kind of glossed over. So the homework, 6.4, is 11 to 35 every other odd, 39, 45, 47 to 71 every other odd. And this completes the online calculus lectures while I'm in Guatemala, and when I get back I will answer all questions from these 3 sections that were assigned online. And so hold all of your homework until I get back, and we'll answer questions, and then you can turn them into me at that time. So I look forward to seeing you guys again, and writing on a blackboard instead of doing it this way. Well, thanks for your attention. Have a good day.